Okay, so the first thing you need to do, if you're watching this, is copy down, pause the video, and copy down these this set of instructions. And then we will move on to our half sheet, which will be on the next page. All right, so now that you have your instructions ready, you're going to follow them. So number one, on the instructions, states that you need to draw a line, your y-axis, all the way down the page. Well, we want that 4 squares from the left. So you're going to count over from the left, 4 squares, and then draw your y-axis all the way down.
How far from the top?
All the way down, all the way up, all the way down. So I'm going to get my 1, 2, 3, 4, and I'm going to draw my y-axis all the way down.
I have a question.
Yes?
Do we need no space to write like measurements on the side? Or
No. It's okay if your holes are right next to it. Also, I highly suggest you do this in pencil because you'll mess up one of these and have to try to erase it. I highly suggest use a pencil. Now, at the bottom of this, I have a little screenshot of the half sheet that everyone has. It has just a scale and then our problems 1 through 6. So let's look at what we're actually given. Okay, at number 1. Well, first of all, let's start with the scale. So we have a distance scale. 1 square equals 0.25 meters. Okay, from now on, just think of that in money. Okay, quarters. $1 equals 4 quarters. Our time scale is 1 square equals 0.1 seconds. And then our amplitude is 1 square equals 5 decibels. All right, so let's look at number 1, what we're actually given. What does A stand for? Amplitude. So our amplitude equals 10 decibels. Now, in previous year, I've just talked about amplitude in meters, just because for ease. Instead, we're actually going to use the appropriate unit, which is decibels. Anyone know what a decibel is? Yes, Chip.
Like force of a wavelength or something like that? It's like how loud something is.
Yes, that's right. We perceive it as volume, as how loud something is. It's the intensity, how powerful per meter a sound wave is. Okay? So that's going to be the height. So the higher your amplitude, the louder we perceive it as. Yes?
Is that why once you get it to a certain decibel, like the tower of how much noise it's making, you can actually lift stuff up with sound?
It vibrates it, yes. Yes. So after that, after our amplitude, we're given this symbol. What is that symbol?
Lambda.
Lambda,
Lambda.
which represents what?
Wavelength.
Wavelength. So our wavelength is 1 meter. Then we're given 5 vibrations. What's another word for vibration?
Movement.
In this context, 5 vibrations is the same as 5 waves. Waves and vibrations are interchangeable. What does F stand for? Frequency, which is what? What's our... That's the unit, but what is frequency?
Number of vibrations.
That's fantastic. Number of waves per second, number of vibrations per second. And then what does P stand for? Our period. Okay, what's the unit for period? Seconds. Yes, if you've not watched the video, then you have no idea what we're talking about. And we'll talk about those and how to calculate them here in a little bit. So the first thing, after we have our y-axis, we need to know where our x-axis is going to go. Now, too high up, and we're going to run out of room for our amplitude. Okay, too far down, and we're just going to waste room. So, as it says on number 2, of those rules that you wrote down, not the half sheet, but the rules you wrote down, you're going to figure out what the amplitude is, and then add one buffer square. Okay, so let's look at number one. Our amplitude equals 10 decibels. So how many squares is that? 4. Okay, so when we're looking at amplitude, we're looking at this scale. 1 square equals 5 decibels.
Oh, it's just
2 squares, okay? So it's going to be 3, yes. 2 squares plus 1 as our buffer is going to be 3. So we're going to go count from the top. 1, 2, 3. And put a dot there. Okay, and then we're going to draw our x-axis from that point all the way across. Okay, that fulfills number 2. Now, number 3 starts talking about dots and dashes. Okay, dots, we're going to put dots along here to represent our wavelength, okay, how long our wavelength is. So, let's look at our wavelength. We have a wavelength of 1 meter, right? How many squares is that? 4 squares. So, we're going to count across 4 squares. 1, 2, 3, 4. Put a dot. So that's 1 wavelength. How many wavelengths do we have for number 1?
5.
5. How do you know?
Because there's 5 vibrations.
5 vibrations. So we need to count across 4 squares 5 times, right? So we have 5 waves. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
Wait, so the one. Okay. No.
So we have 5 wavelengths. We have 5 segments now. Okay. 5 vibrations. Next thing, number 4 says in between each dot along your x-axis, make your dashes. Okay, so you're going to go through here and you're just going to make a dash in the middle.
You know why is that? Okay, so
This is your blueprint showing every place that your wave crosses the x-axis. You're making a connect the dots. Actually, a puzzle that you're going to connect using your dashes and dots. Now, here's the thing. Let's say there's a different example. Okay? Let's say your wavelength is 3 squares. Okay? Where would you put your dash? 1.5. That's right. So it always goes in the middle. So it doesn't matter if it doesn't end up on necessarily at a junction, at a cross between horizontal and vertical of your grid lines. Okay, so we have our dots and dashes. Next thing we need to do is put our dots where our amplitude goes, okay? How high our wave and how low our wave goes. Put a dot where our crest is, put a dot where our trough is. Now we already have this set up, so how many squares is our amplitude again? 2 squares up, 2 squares down, right?
Yeah.
So we're going to go in between our dot and your dash, up 2 squares. That's going to be our crest. So you always go in between, and then you go between your dash and your dot down 2 squares.
Oh. So it rotates.
Yep. So you're going up, down, up, down, up, down. So just continue that pattern. Yes. 8 dots. How many dots do you have? 10 dots, right? 10 dots? Not right.
I've got 11. Oh, I did not do the last one.
you always want to, right, you're only going in between dots and dashes. You don't want to go further.
Oh. Wait, why are we doing that again?
Because this is our pattern. Now we're just going to connect the dots.
Oh.
Wait, shoot, I think I did it wrong.
Okay, now, when you look at it, an easy way to check is that, remember, another definition of wavelength is distance between crest and trough, right? So your dots should be 4 squares away from each other, right? There should be 4 squares in between each of your dots on the crest and 4 squares between your troughs. Okay?
When you connect the dots, do you want them to be straight or do you want them to be curved?
You can either do curvy like that, or you can do straight. That is up to you, whichever you decide. Your preference. Just as long as it's symmetrical is what I like here.
It has to go through all those points, right?
Yes, so all of your points. So notice the dashes are where your wave crosses the x-axis, same as where your dots. Okay, now that we have our pattern drawn, are we done with number 1?
No.
No. What do we need to do next?
You have to find the FP.
That's right, you gotta find the fricacy.
What? Oh, I was like,
Fricacy, that's what it says. Okay, and what's the definition of frequency?
how frequent,
Something
how many waves
That's right, how many waves per second? Okay, so do we have our second mark up here? No, we haven't marked our time yet. So that's what we're gonna do next. We're gonna make a universal 1 second line all the way down. Okay, so we only have to do this one time per page. So how many squares make up 1 second?
10 squares.
10 squares, why?
Because it's 0.1 of a second each square.
It's a 1/10 of a second, so it's gonna take 10 squares to equal 1 second, right?
Yes.
Okay, so that means that we are going to draw a dashed line at 10 seconds. Now, I would count twice just to make sure you don't miscount, because you don't want to put 1 second line all the way down the one spot. So I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to make my dashed line all the way down.
Squares, 1 second.
A 1/10 of a second, yes, 0.1 second. So 10 squares is going to equal 1 second.
All the way down to the.
All the way down.
Like to the very bottom.
All the way down. It can be as long as you want it to be, just as long as it goes all the way down.
What?
It's like the model.
Yes, dash line. No, just make it all the way down. Now we have our 1 second mark. Now we can draw it all the way down because we're going to start all of our waves at the same point, right? Because our y-axis here is not going to move. So that means our 1 second line is not going to move. So this just Saves us the time of having to do this, find the 1 second mark for every wave. Okay. Now, our definition of frequency is number of, can't exactly write with that. Number of waves per seconds. Okay? Now, how in the video, the notes, how did we find the frequency?
Okay, so we calculate how many noise is present for one bit over 1 second.
How do I do in the video? No.
Add the amount of crests and troughs and then divide by
Thank you so much. You add the crests and the troughs in the 1 second and then divide by 2. Okay, so we have 1, 2, 3 crests. We have 2 troughs.
5. So it's going to be 2.5.
So it's going to be 5 divided by 2 equals 2.5. And what's our unit? Hertz.
What's your name?
With a Z.
Okay.
Yes. Yes, you're just writing this just like I have on my graph paper.
So is that why like the higher the pitch of like a note is, the more hertz it is?
Yes,
You mean to write
a
that?
higher frequency. No, you have that in your notes. Now what? What else do we need?
Heat.
That's right. We need our period, which means we can do this 2 ways. Now, what's our formula for period? 1 over f. So we can either do 1 over 2.5 hertz. That's assuming that we got the frequency right. Okay? But if we didn't get the frequency right, then we're also going to screw up our period. So a good way to do this is to look at your graph. Okay? The period is how many seconds per wave. So where's one wave? One crest and one trough. So this is one wave, right? One crest, one trough. So how many seconds is that?
0.3.
Second.
It's 3.3. Because if there's 10 and that's... Oh, wait, that's 4.
0.4 seconds, right?
Yeah, it goes 3.
0.4 seconds. If you put 1 divided by 2.5, what do you get?
2.5. No.
1 divided by 2.5.
You get something. Oh, going forward.
You get 0.4. Okay, so that's your check. That's to make sure that you did the frequency right. Right?
Yeah.
So if you look at your graph and you get 0.4 in this case, and you put 1 divided by whatever you got for your frequency, and they equal the same number, that means you did both of them right. That's your check. Question? No, we're not worried about 2 sig figs right now. Yeah, for these drawings. And then we're done for number 1. Okay, so for number 2, the first thing you need to do is figure out where your x-axis is going to go. So what's your amplitude? Okay?
So it'd be 4. Wait, yeah.
It'll be 4 squared plus 1, so it's 5. Now, one of the big issues I've seen are people counting from the other x-axis. You don't count from this. You count from the bottom of the other way down. So that'd be 1, 2, 3, 4, 5. Put a dot. That's where my next x-axis is gonna go.
Oh, okay.
Okay? And you're gonna use those same steps to continue 2 through 6.